Welcome to Are You Chemistry GCSE Ready? This playlist takes you through loads of example questions and guided solutions for every single topic in your chemistry GCSE. So it's a perfect way for you to test your chemistry knowledge. If you feel like you need a quick review or you just want the ideal revision companion for these videos, then make sure to download my free chemistry GCSE revision notes. I've linked them in the description below. Or if you're ready, let's dive straight in.
Acids and bases. So what is an acid and what is a base? So an acid is something that releases positive hydrogen ions when it dissolves, and you just need to learn that definition. Whereas your base is something that will react with an acid to form a salt and a water. And that's called a neutralization reaction, because if you then measure the pH of that solution that you get, you will find that it is 7 or neutral. An alkali dissolves to release these hydroxide ions. Okay, so that's the difference between your alkali and your acid, these negative hydroxide ions. And they're essentially just soluble bases. Okay, so all alkalis are bases, but not all bases are alkalis because some bases are insoluble. Just to show you this equation here, so this is just showing you that if you take those positive hydrogen ions and combine them with these negative hydroxide ions, you can see that I can form water from combining those two things. Identifying substances. So how do we actually identify between acids, bases, alkalis and salts? So you can use this flow chart if it helps you. Your first protocol is it an acid? So the acids you need to know are hydrochloric acid, sulfuric acid, nitric acid and ethanoic acid as well. If yes, then it's an acid. If no, next question, is it a base? So if it's a base, it's either a metal hydroxide, metal oxide, or metal carbonate. So you're looking for the endings, a metal OH hydroxide, O oxide, or CO3 for metal carbonate. No, well then, is it an ionic compound? If it's an ionic compound, it's a salt. Because remember, it could be not any of these things, okay? Or yes, then you need to filter it slightly further and ask yourself, is it an alkali? In other words, is it soluble? Is it a soluble base? Or is it NH3? Is it ammonia? If the answer is yes, then it's an alkali. pH scale now. So what affects the pH scale? So a high concentration of positive hydrogen ions gives me a low pH. Remember, your low pHs are things that are acidic, so that makes sense. Low concentration of these positive hydrogen ions means you've got a higher pH. Or actually, I could say as well, a high concentration of these hydroxide ions leads to a high pH, because high pHs are my alkalis. So if I have a very high concentration of hydroxide ions, then my substance is an alkali. How do we measure it? Well, you can use different things. You can use a pH probe. It's very precise, it's very accurate, a digital probe. Or you can use some kind of indicator. So if you use a universal indicator, that can show you the gradual colour change as you go from acidic reds up to alkaline kind of purples. Or you can use one of the following things. Methyl orange, you can use phenolphthalein or litmus, and that will only show you if the solution is acidic or alkaline. So that's more of a binary. Is it acidic? Is it alkaline? So it's not as gradual as your indicator, universal indicator. Reactions of acids, so turn the following into balanced symbol equations. We've got calcium plus hydrochloric acid. So calcium is a metal, hydrochloric acid is obviously an acid, and I know not my mnemonic MASH, metal plus acid gives me salt and hydrogen. And so let's write calcium plus hydrochloric acid. And then what kind of salt am I going to get? Remember, I take my metal name, so calcium, and then because it's hydrochloric acid, it's going to be calcium chloride.
And let's look at those ions involved in that ionic compound. So we've got calcium with a +2 charge, and we've got chloride ions with a -1 charge. Those are not balanced. So I need to add another chloride ion there. So I've got +2 and -2, and that's my formula CaCl2. Remember, in order to know what charges these ions have, I needed to look at what group they're in the periodic table. So calcium's a metal in group 2, so it loses 2 of its outer electrons to become a +2 ion, and every one of your chloride ions becomes an ion by gaining 1 electron to fill their outer shell. Plus H2, hydrogen, you should know, is a diatomic molecule. Now I'm balancing it. So on my left-hand side, I just put a 2 in front of my hydrochloric acid, because on my right-hand side, I had 2 hydrogens, but with just hydrochloric acid, I only had 1 on my left-hand side. So now I've got 2 of each, but this has done another thing. I've also now got 2 chlorine on the left, 2 chlorine on the right, and Ca, 1 calcium on the left, 1 calcium on the right. So I'm all balanced now. Okay, nitric acid plus sodium carbonate. So we've got an acid here plus a carbonate. So this is our quarks. Carbonate plus acid is water, carbon dioxide, and salt. And so nitric acid formula there, plus sodium carbonate. Now I need to see what that compound's going to look like. So sodium forms these positive +1 ions. Carbonate's one of the complex ions you need to learn, has a -2 charge. So I need 2 sodium ions to balance that carbonate -2 charge. +2 -2, perfect. Na2CO3. That gives me water, H2O, plus carbon dioxide, CO2, plus my salt. So that's going to be, again, the metal name, so sodium. Nitrate, because it's made with this nitric acid. And those 2 ions there, again, your nitrate ions are ones that you need to know as a complex ion. You need to know has a -1 charge. Your sodium, your sodium has a +1 charge. And so there you have it. You have 1 sodium and 1 nitrate ion. Am I finished here? No. Let me have a look. Because if I look at my sodiums, on my left-hand side there's 2. On my right-hand side there's only 1. So I need to add a 2 in front of that sodium nitrate on my right-hand side. Now, is everything balanced? Well, no, actually, because if I look at, for example, my hydrogen, I've only got 1 on my left-hand side and I got 2 on my right-hand side. So I need to put a 2 in front of my nitric acid there. Now, is everything balanced? Okay, my hydrogens are nitrogens, yes, they are. My oxygens, well, let's check. So 2 times 3 for that nitric acid gives me 6, and then +3 coming from this carbonate on my left-hand side is 9. 1 from my water, 2 from my carbon dioxide, 3, and then 2 times 3 of that oxygen from that nitrate gives me 9 on my right-hand side in total as well. Good, 2 sodiums on the left and the right, and carbons are all accounted for as well. There's only 1 on the left and only 1 on the right as well.
Just before we go into the tips and tricks section, if you do want some extra advice to getting that grade 9 for your GCSE, then why not download my free 20-minute exam success guide? Just click on the link in the description below. I'm going to give away all of my best advice and secrets, and completely for free, so why not?
Make sure you can recognize acids and alkali from both the name and the formula. Yes, so make sure you are confident with those, no matter which one they give you. Sometimes it can be a process of elimination as the best way to identify what a substance is. So you can go through that process that we did on slide 2 to help you. Make sure you always link an explanation about pH to the change in your concentration of hydrogen ions, okay? So a high concentration of hydrogen ions means a low pH, and a low concentration of hydrogen ions or a high concentration of hydroxide ions means a high pH.